Students, today we cover the science chapter Chemical Reactions and Equations CBSE Class 10. Learning Goals. Chemical Reaction. Reactant and Product. Chemical Equation. Chemical reaction, the transformation of chemical substance into another chemical substance is known as chemical reaction. For example, rusting of iron, setting of milk into curd, digestion of food, respiration, etc. In chemical reaction, new substance is formed which is completely different in properties from the original substance, so in a chemical reaction chemical change takes place. Signs of chemical reaction. Change of state of substance. Change of color of substance. Evolution of heat. Absorption of heat. Evolution of gas. Evolution of light. Evolution of sound, etc. Reactant. Substances which take part in a chemical reaction are called reactants. Product. New substance formed after a chemical reaction is called product. Chemical equation. Representation of chemical reaction using symbols of substances is called chemical equation. Example, A and B, C and D. In this equation, A and B are called reactants and C and D are called the products. Arrow shows the direction of chemical reaction. Condition, if any, is written generally above the arrow. When hydrogen reacts with oxygen, it gives water. This reaction can be represented by following chemical equation. Hydrogen and oxygen water. H2 plus O2 H2O. In first equation words are used and in second symbols of substances are used to write the chemical equation. For convenience, symbol of substance is used to represent chemical equations. Chemical equation is a way to represent the chemical reaction in concise and informative way. Chemical equation can be divided into two types, balanced chemical equation and unbalanced chemical equation. Balanced chemical equation. A balanced chemical equation has number atoms of each element equal on both sides. Example, Zn and H2 SO4 ZnSO4 plus H2. In this equation, numbers of zinc, hydrogen, and sulfate are equal on both sides, so it is a balanced chemical equation. Unbalanced chemical equation. If the number of atoms of each element in reactants is not equal to the number of atoms of each element present in product, then the chemical equation is called unbalanced chemical equation. Example, Fe and H2O Fe3O4 plus H2. In this example number atoms of elements are not equal on two sides of the reaction. For example, on the left-hand side only one iron atom is present, while three iron atoms are present on the right-hand side. Therefore, it is an unbalanced chemical equation. To balance the given or any chemical equation, follow these steps. Fe and H2O Fe3O4 plus H2. Write the number of atoms of elements present in reactants and in products in a table, as shown here. Balance the atom which is the maximum in number, on either side of chemical equation. In this equation, the number of oxygen atom is the maximum on the RHS. To balance the oxygen one needs to multiply the oxygen on the LHS by 4, so that the number of oxygen atoms becomes equal on both sides. Fe plus 4x H2O Fe3O4 plus H2. Now, the number of hydrogen atoms becomes 8 on the LHS, which is more than that on the RHS. To balance it, one needs to multiply the hydrogen on the RHS by 4. Fe plus 4x H2O Fe3O4 plus 4x H2. After that number of oxygen and hydrogen atoms becomes equal on both sides. The number of iron is 1 on the LHS, while it is 3 on the RHS. To balance it, multiply the iron on the LHS by 3. 3 Fe plus 4 H2O Fe3O4 plus 4 H2. Now the number of atoms of each element becomes equal on both sides. Thus, this equation becomes a balanced equation. After balancing, the below equation can be written as follows. 3 Fe plus 4 H2O Fe3O4 plus 4 H2. Balance the given equations. H2 plus O2 H2O. Answer, 2H2 plus O2 2H2O. Fe and H2O Fe2O3 plus H2. Answer, 2 Fe plus 3 H2O Fe2O3 plus 3 H2. Co2 plus H2O C6 H12O6 plus O2. Answer, 6 Co2 plus 6 H2O C6 H12O6 plus 6 O2. Fe2O3 plus C Fe and Co2. Answer: 2 Fe2O3 plus 3C4F. By writing the physical states of substances, a chemical equation becomes more informative. Gaseous state is represented by symbol G. Liquid state is represented by symbol L. Solid state is written by symbol S. Aqueous solution is written by symbol AQ. Writing the condition in which reaction takes place, the condition is generally written above and / or below the arrow of a chemical equation. Thus, by writing the symbols of physical state of substances and condition under which reaction takes place, a chemical equation can be made more informative. Double displacement reactions, reactions in which ions are exchanged between two reactants forming new compounds, are called double displacement reactions. AB and CDAC and BD. Example: when solution of barium chloride reacts with the solution of sodium sulfate, white precipitate of barium sulfate is formed along with sodium chloride. BaCl2 plus Na2 SO4 BaSO4 plus 2 NaCl. When sodium hydroxide, a base, reacts with hydrochloric acid, sodium chloride, and water are formed. NaOH and HCl, NaCl and H2O. Double displacement reaction, in which precipitate is formed, is also known as precipitation reaction. Neutralization reactions are also examples of double displacement reaction. Reactions which produce energy are called exothermic reaction. On the other hand, reactions which absorb energy are called endothermic reaction. Most of the combination reactions are exothermic. Most of the decomposition reactions are endothermic. Respiration is a combination reaction in which energy is released. When quicklime, calcium oxide, is added to water, it combines to form calcium hydroxide and releases energy. Cooking involves chemical reactions which are endothermic, as cooking is possible because of heating. Oxidation, addition of oxygen or nonmetallic element or removal of hydrogen or metallic element from a compound, is known as oxidation. Elements or compounds in which oxygen or nonmetallic element is added or hydrogen or metallic element is removed are called to be oxidized. Oxidizing agent, compounds which can add oxygen or a nonmetallic compound or remove hydrogen or metallic element are known as oxidizing agents. Reduction, addition of hydrogen or metallic element or removal of oxygen or nonmetallic element from a compound is called reduction. The compound or element which goes under reduction is called to be reduced. Reducing agent, compounds or elements which can cause reduction are called reducing agents. In a chemical reaction, oxidation and reduction both take place simultaneously, and such reactions are also known as redox reactions. In the word redox, red stands for reduction and ox stands for oxidation. Example: when iron reacts with air, it forms iron oxide, rust. 4 Fe plus 3O2 2 Fe2O3. In this reaction, oxygen is added to iron, thus, iron is oxidized. Here oxygen is oxidizing agent. When cupric oxide reacts with hydrogen, it gives copper and water. CuO and H2 Cu and H2O. In this reaction, oxygen is removed from copper and oxygen is added to hydrogen. So, cupric oxide is reduced to copper and hydrogen is oxidized to water. Cupric oxide is oxidizing agent and hydrogen is reducing agent. When sodium hydroxide reacts with hydrochloric acid, it gives sodium chloride and water. NaOH and HCl, NaCl and H2O. In this reaction, sodium hydroxide is reduced to sodium chloride since hydrogen is removed from sodium hydroxide. Hydrochloric acid is oxidized to water, since oxygen is added to hydrogen chloride and nonmetallic element chloride is removed. Sodium hydroxide is oxidizing agent and hydrochloric acid is reducing agent. In this reaction, oxidation and reduction both takes place simultaneously, thus it is an example of redox reaction. Respiration is oxidation reaction in which food is oxidized to produce energy. Iron gets oxidized to form rust, which leads to corrosion of iron in the long run. Most of the metals react with atmospheric oxygen and it leads to formation of a layer on the metal article. The metal gets corroded in the long run. Rusting of iron can be prevented by painting the iron article. This can also be prevented by applying a layer of zinc over iron article. This process is known as galvanization. Fried food gets oxidized when exposed to air. This spoils the taste of the food and the food becomes unfit for consumption. The spoiling of fried food because of oxidation is called rancidity. Fried food is often packed in airtight packets to prevent rancidity. We are able to utilize various types of fuel because of oxidation. Oxidation of fuel helps in producing energy. Thank you. Please make sure to like this video and subscribe to our channel. We hope you have understood the lesson. We wish you the very best. Until next time, bye.